Okay, Assalamu alaikum dear student. Today we are going to solve this 970221 of May June 2016. यहाँ पर एक चीज़ जो बड़ी इम्पोर्टेंट है वो समझ लें कि एक तो जो है वो यहाँ पे आपके पास जो डाटा होता है या ये जो आपके पास फार्मूलाए दिए हुए हैं, ये अगर आप देखेंगे तो ये फर्स्ट ईयर और सेकेंड ईयर यानी AS और A2 दोनों के इसमें जो है ना वो चीज़ें आपको मिलेंगी। और ये जो है वो जो डाटा है या ये जो फार्मूला है इस पर डिपेंड आप नहीं कर सकते, तो लिहाजा कोशिश ये करें कि जो भी आपके पास चैप्टर्स हों उनके स्पेसिफ़िक जो डेफिनेशंस हैं और जो इक्वेशंस हैं वो आपको याद होनी चाहिए ताकि आप उसको यूज़ कर सकें। ये जो है वो नाकाफ़ी फार्मूलाए हैं, तो डोंट डिपेंड ओनली ऑन दिस शीट, दिस इज़ वेरी इंपॉर्टेंट। दूसरी बात जो मैं आपसे कह रहा हूँ वो ये है कि मैं इस पेपर को जो है समझ लें डिवाइड करके सॉल्व करूँगा और हर दिन तकरीबन हम 2 से 3 क्वेश्चन पर सॉल्व करेंगे और अपलोड करेंगे, तो आप जो है वो इसको मुकम्मल तौर पे देख सकते हैं। ज़्यादा लंबी वीडियो हो जाती है तो फिर वो आपके लिए भी बोरिंग हो जाती है, और जो है वो समटाइम्स जो होता है कि एक क्वेश्चन आपको समझ में आया हुआ है, अब बिला वजह में पूरे का पूरा आपने उसको देखना है, तो हम इसको पीसेस में डिवाइड करके सॉल्व करने जा रहे हैं। तो दिस इज़ द फर्स्ट क्वेश्चन ऑफ दिस पेपर। या मैंने इसको बेसिकली सॉल्व किया हुआ है ताकि कम से कम टाइम में इसको जो है वो हम देख सकें और इस पर बात हो सके। क्वेश्चन 1 सेज दैट A मेक एस्टिमेट्स ऑफ 1 द मास इन kg ऑफ द वुडन रूल मीटर रूल। तो अब ज़रा ये जहन में रखिए कि वेन एवर यू आर टॉकिंग अबाउट एस्टिमेट्स देयर विल नॉट बी एनी फिक्स वैल्यू, सो देयर विल बी अ सॉर्ट ऑफ रेंज। तो आप ये कह सकते हैं कि 50 से 200 ग्राम का या 10⁻³ अगर ले रहे हैं तो किलोग्राम की वैल्यू का एक आपके पास जो है वो वुडन मीटर रूल हो सकता है। तो वॉट एवर द वैल्यू यू आर राइटिंग हेयर, यानी वेदर यू आर राइटिंग हेयर से 80 into 10⁻³ or any value in between these two, the answer will be considered as the correct answer. तो ये रेंज है जिसमें आपको जो है वो आंसर लिखना है। सेम इज़ द केस फॉर द वॉल्यूम, सेकंड पार्ट, द वॉल्यूम इन सेंटीमीटर क्यूब ऑफ अ क्रिकेट बॉल और अ टेनिस बॉल। तो अगेन यू मे हैव दिस रेंज 50 to 300 centimeter cube. This time the unit is centimeter cube, so you need not to change or convert this into meters, and they are asking in centimeter cube. So again this is the sort of range which you can consider, and whatever the values you are writing, suppose you are writing here 200 centimeter cube, this will be a correct answer, or 55 or 65 or whatever. This is the range in between your answer will be considered as the correct answer. So you need not to write the range, but only one answer is required, and obviously here as the unit is centimeter cube, so obviously you need not to change anything. Then in part B you can see a metal wire of length L has a circular cross section of diameter D as shown in figure. अब यहाँ उसने आपको जो है वो एक मेटल वायर दिया हुआ है और उसकी लेंथ उसने आपको बताई हुई है कि लेंथ L है, and the cross section of the diameter D is given. So it means that the cross section, what is cross section? This is the front, or you can say something like this. So this is the cross section of the wire, and the diameter is given as a D. So whether you are taking this line or this line or whatever the line you are drawing here, this will be the diameter, and you can write the value as D. Then they are saying that the volume of the wire is given by the expression. Now they have given you the formula here. Basically whenever we have these type of questions, we need not to worry about that from where this formula is coming. Actually we can drive this formula, but for the time being when the question is different, you need not to worry about the formula, that from where this formula is coming. You have to only concentrate on the given formula, and accordingly you will utilize this formula for the calculations ahead. The diameter, length and mass m are measured to determine the density of the metal of the wire. The measured values are, अब एक तो सिंपल सी बात यह है कि जब वो आपसे ये कह रहा है कि डेंसिटी का तस्करा कर रहा है, तो यू ऑलरेडी नो दैट डेंसिटी इज़ नथिंग बट mass per unit volume. So from where you can calculate the volume? So here you have the formula, and mass obviously is given directly. Indirectly, they have given you the values of D and L, which you will use obviously in this formula, and you will get the volume. So this is the basic concept. Now as far as the conversions are concerned, you can say and see that answer is also very important in kg meter per cube. So it means that here we have centimeter and millimeter, centimeter in length, and for your diameter they have given you the unit as millimeter. So what you have to do, you have to convert these values. तो इस बात का ख्याल रखने की ज़रूरत है. कन्वर्जन जो है वो मैंने यहाँ पर आपको लिख के बताया है कि ये कन्वर्जन्स हैं. वैसे तो आपको ये आते ही हैं, लेकिन रिकॉल कर लें तो कोई हर्ज नहीं है. So what you are doing now, you are using this formula, given formula V is equal to pi d square L over 4, and obviously 0.38 into 10 to the power minus 3. Why? I have already explained that here you have millimeter, and when you will convert this millimeter into meter, this will be equal to 10 to the power minus 3. So this is one thing. Same is the case for length, and as far as the length is concerned, I think it's good idea to write if they have given you the capital letter L, so you can also use the capital letter L here. But again, I was talking about the conversion of the unit. So here you have 25.0, and obviously centimeter, when you will convert into millimeter, you have this situation that 10 to the power minus 2 is coming as 1 meter is equal to 10 to the power minus 2 centimeter. So this is something which is very important, and here you are converting this value. Rather, actually this is the other way around situation. This is 1 centimeter, 1 centimeter, which is equal to 10 to the power minus 2 meter. This is not the conversion. Here you have the right conversion. 1 millimeter is equal to 10 to the power minus 3. But here you have the conversion. 1 centimeter is equal to 10 to the power minus 2 meter. And that's why you have used here 25.0 with 10 to the power minus 2 thing. And when you are calculating the value of V, this is the value you are getting. So this is the volume of the wire. Fine. So this is the volume of the wire, and already they have given you the mass. Here you have the mass. Here again you have this situation that the unit is giving as gram. So you have to change this again into kilogram. So 1 gram is equal to 10 to the power minus 3 kilogram. Or you know that 1 kilogram is equal to 1000 grams. So according to this conversion, again you have 10 to the power minus 3 here, and with volume you have already calculated this thing, and the answer is coming as 7940 kg per meter cube. And if you will convert this into decimal, in the powers, 10 to the power 10 to 7.9 into 10 to the power minus 3 you can write. But at this stage you can leave 7940 for the time being. Now the point is you need to calculate the absolute uncertainty of the density as well. So you should know that the formula of the density, as I have mentioned here, is simply density is equal to mass per unit volume. But when you will use the formula given for volume here, something like this you are getting: rho is equal to m divided by pi d square L divided by 4. And when you will rearrange this whole thing, 4m divided by pi d square L is coming. Now as far as the absolute uncertainty is concerned, you need not to consider the constants thing in the formula. So 4 and pi, they are constants, so you need not to consider these two things, these two numbers as for your calculation. Now as far as the uncertainty is concerned, you know that the fractional uncertainty of density will be equal to sum of the fractional uncertainty of mass, fractional uncertainty of diameter. Here as you have square, so as far as the formula is concerned, it becomes 2 and absolute and fractional uncertainty of d. And then obviously you have length as well. So you can write here that del L divided by L, any fractional uncertainty of length, you are going to add as well. You can write in this way, or you can use here the percentage uncertainty. The whole thing you can write in percentage, but there will be no major effect as far as the answer is concerned. So whether you are using the percentage thing or you are using the fractional uncertainty, the answer will be same. So that's why I'm not using for the time being the percentage thing. I'm just using the fractional uncertainty concept, and obviously all these values you have. So mass 0.001, 0.001 here you have, divided by 0.225, 2 into 0.01 divided by 0.38, and for length you have here 0.1 divided by 25.0. And when you will calculate this, obviously you have already calculated the density thing, so you can multiply 7940 and then you will get the uncertainty. Which uncertainty? Absolute uncertainty in the density. So this is very important. So what you are getting here, 484.6. Try to solve yourself as well. But normally as far as the you can say absolute density is concerned, we use only one significant figure. So here we have this equation or conversion. So we can write 500 when you will take the 484.6, you can write 500, and you can even write 0.5 into 10 to the power 3, which you have written here as well. So simple answer will be 7.9 into 10 to the power minus 3, and from this side you are getting 0.5 into 10 to the power minus 3, and you can take 7.9 plus minus 0.5, and obviously you are taking 10 to the power minus 3 out of the bracket or common, you can say. So 7.9 plus minus 0.5 into 10 to the power 3, this will be your answer. I hope it's clear. If you have any problem, please ask. And one more thing which I can mention here, that if you have any confusion as far as the absolute uncertainty or certainty is concerned, I have already discussed in one of my chapter, you can say, or in a topic of uncertainty, and you can go to my channel and you can go through in detail that what you have to do when you are dealing with uncertainties thing. Okay. Then we have question 2, and in question 2 you can see that the question is basically the projectile motion. If you have studied projectile motion, as soon as you will see this diagram, you will say that the question is of a projectile motion. As far as the projectile motion is concerned, you must know that there are two basic conditions or assumptions for projectile motion. One is given here, air resistance is negligible, and the second one, or the most important, is that the motion is under gravity. Projectile motion is always under gravity. So remember this thing, that if you have any body which is moving under gravity, then you can say that the motion will be the projectile motion. Otherwise, obviously the projectile motion will not be here. Anyhow, again, I can say that, or I can advise you that go to my chapter, the projectile motion, which I have already discussed in one of my you can say lesson, and you can see that what actually the factors and considerations we have to be careful in the projectile motion. Now the question is, a ball is thrown from a point P with an initial velocity u of 12 मीटर पर सेकेंड एट 50 डिग्री टू दी हॉरिजेंटल. अब यहाँ पर ये बेसिक एक चीज़ है कि आपके पास एक जो है वो बॉल है जिसको आपने एक इनिशियल वेलोसिटी से थ्रो किया है. इनिशियल वेलोसिटी उसने आपको दी हुई है 12 मीटर पर सेकेंड, और एंगल जो है वो 50 डिग्री का है। अभी जैसे मैंने आपसे कहा कि ये पार्ट पढ़ते ही आपको अंदाज़ा हो जाना चाहिए कि आपके प्रोजेक्टाइल मोशन का क्वेश्चन है और आपको सारा जो आपने प्रोजेक्टाइल मोशन की थ्योरी पढ़ी है उसको रिकॉल करने की ज़रूरत है अपने जहन में, ताकि इस क्वेश्चन को आप सॉल्व कर सकें। The ball reaches maximum height at Q. So they are saying that the maximum height is at a point Q. Again, as I said, that basically these two are two basic conditions for a body to have the projectile motion. Part A, calculate the horizontal component U. So what actually you can do here, the velocity, initial velocity of the ball is given. So you can resolve this velocity into two components. Basically, again, you have to recall the vector thing. So this is the horizontal component, and here you have the vertical component. Obviously, here you can write UH and here you can write UV to say that this is vertical and horizontal respectively. So this is what we have. So they are saying horizontal component of U. So what is the horizontal component of U? So you know that here you have basically the X component. So with X component, according to this angle, you have this formula Ux is equal to UH, yani horizontal component will be equal to U cos of theta. And obviously it's very simple, put the value, get the answer situation. U is 12, cos is 50. So when you will multiply and calculate, you will get 7.7 meter per second. This is your horizontal velocity. Just to remind you that horizontal velocity will always remain constant throughout the projectile motion. So this is very important. Second part is the vertical component of U. So vertical component, as I said, that here you have the vertical component, and according to this angle 50, obviously you have to use this formula कि Uy is equal to Uv U sin theta. Again, put the value, get the answer situation. So you have the value 9.19, which you can write as 9.2 with this significant figure 9.2. Yani two significant figures. Here you have the two significant figures. So these are the basic calculations. One is for the horizontal component, the other one is for the vertical component. Now in second part, what they are asking, show that the maximum height reached by the ball is 4.3. अब एक बात ये याद रखिए कि whenever you have a question like this, show that, so I think the question is very simple or easy because you know what is the answer. You have to actually only you can say go to this answer 4.3, and if you can recall the third equation of motion, which is 2as is equal to v square minus u square, where s is the distance covered or displacement, v is the final velocity, u is the initial velocity. So as far as this situation is concerned of projectile motion, you need to consider here that distance covered is nothing but height, obviously, and here you have the vertical motion, so final vertical velocity, and here you have the initial vertical velocity. So when you will consider all these things, you have to recall this situation as well, that at maximum height, the vertical component is slowly and gradually decreasing, and when the body reaches to the maximum height, its vertical component of the velocity becomes zero. As far as the horizontal component is concerned, I have already told you that it will remain the same throughout the projectile motion. So what you are saying, that whatever the height we have to calculate, how we can calculate, the G is here 9.81 here. So this is the value of your G. As I said, that at highest point the vertical velocity, final vertical velocity, you can say becomes zero, and initial vertical velocity you have already calculated here. So this velocity you are using, and then very simply you can calculate height. This is nothing but height, or y. Y is also showing you that you are talking about the vertical displacement. So whether you are considering the vertical displacement or height, the same thing. Now they are saying in part C, determine the magnitude of the displacement PQ, displacement. So when they are saying displacement, you have to recall that displacement is nothing but the shortest distance between 2 points. So if you will consider this distance PQ, this will be the displacement PQ, because this is the shortest distance. And when you will consider this line or this vector, you can say, as far as the displacement is concerned, so you have two components. One is, suppose this is your O, point O, so this is your X from P to O. You can say that P to O is displacement X, and from this point O to Q, you have OQ, which is nothing but Y, any vertical component or horizontal component of the displacements. So basically these are two very important things which you have to consider here. But before this, one more parameter you have to consider, because when you will consider or when you want to calculate the final displacement, you need to calculate X and Y both. Y here you have already calculated, but as far as the X is concerned, obviously you have to calculate this thing, यानी horizontal component जो है ये वाला डिस्टेंस जो है ये भी आपने कैलकुलेट करना है. अच्छा, इसके लिए बहुत सिंपल सा फार्मूला है, S इज़ इक्वल टू वी टी. अब इसको यहाँ अगर आप लिखें तो यूँ लिख दें कि x इज़ इक्वल टू यू एक्स इंटू टी. मसला ये है कि यहाँ टाइम मौजूद नहीं है, लेकिन आसानी ये है कि कॉन्सेप्चुअल अगर आप बेस डिस्कशन पे जाएंगे तो आपको पता चलेगा कि टाइम टू कवर दिस हॉरिजॉन्टल डिस्टेंस विल बी सेम एज द टाइम रिक्वायर्ड टू कैलकुलेट द वर्टिकल डिस्प्लेसमेंट. यानी जब हम प्रोजेक्टाइल मोशन की बात करते हैं तो टाइम वो पैरामीटर है जो हॉरिजॉन्टल डिस्प्लेसमेंट और वर्टिकल डिस्प्लेसमेंट के लिए सेम रहता है. और चूँकि हम वर्टिकल कंपोनेंट की पहले बात कर चुके हैं तो उसकी हेल्प से हम टाइम निकाल सकते हैं. क्या फार्मूला है साहब? फर्स्ट इक्वेशन ऑफ मोशन v इज इक्वल टू u प्लस ए टी, एंड फॉर आर वर्टिकल कंपोनेंट थिंग हेयर वी आर के v इज इक्वल टू यू वी माइनस जी टी. यू वी आप पहले ही बात कर चुके हैं, फाइनल वर्टिकल वेलोसिटी इज़ ज़ीरो. इनिशियल वर्टिकल वेलोसिटी जिससे हम पहले बात कर चुके हैं कि कैलकुलेट की जा चुकी है, एंड विद द हेल्प ऑफ दिस वी कैन कैलकुलेट टाइम. सो दिस टाइम विच वी हैव जस्ट कैलकुलेटेड will not be only for the vertical thing, but the time will also be same for the horizontal displacement. So simply you can say that what we are doing here with the help of this time, which is coming as 0.94, here we have calculated the horizontal velocity initially. So when you will use these two values, you will get the x, यानी horizontal distance आपके पास आ जाएगा. अब ये आपके पास हॉरिजॉन्टल डिस्टेंस आ गया, पहले आप जो है वो वर्टिकल डिस्टेंस निकाल चुके हैं. तो अगर आप पैथागोरम यूज़ कर रहे हैं, पैथागोरस थ्योरम फॉर द ट्राइंगल पी ओ क्यू, तो सिंपली यू विल गेट पी क्यू स्क्वायर इज इक्वल टू एक्स स्क्वायर प्लस वाई स्क्वायर, या यूँ करके लिख दें कि पी ओ स्क्वायर इज प्लस ओ क्यू स्क्वायर. और ये वैल्यूज अब आपके पास मौजूद हैं. हेयर यू हैव ऑलरेडी कैलकुलेटेड हाइट विच इज़ 4.3, which is nothing but OQ in this case, and just now you have calculated the X thing, which is 7.23, which you are using here, and with the help of these two the result you are getting is nothing but 8.4. यहाँ एक बात का ख्याल रखिए कि जब आपके पास यहाँ पर बताया गया है कि साहब 4 मार्क्स का क्वेश्चन है, तो आपको ये ख्याल रखना है कि ये किसी डायरेक्ट फार्मूले से नहीं होने वाला. So be careful of this marks thing as well. So if you have 2 marks, the method will be different. If you have 4 marks, then the situation will be different, and you have to be very careful according to the marks as well. यहाँ हम आज रुक रहे हैं और इंशाल्लाह नेक्स्ट जो है वो वीडियो में हम नेक्स्ट 2 क्वेश्चंस या 3 क्वेश्चंस पर डिस्कस करेंगे. उम्मीद है कि ये जो मैंने आज डिस्कस किया है ये आपको समझ आ गया है, और इंशाल्लाह इसको फिर हम जो है वो जैसे मैंने आपसे कहा कि कंटिन्यू करेंगे. कोशिश करें कि थोड़ा थोड़ा करके जो है ना इसको कंप्लीट करते जाएं. हम कोशिश करेंगे कि जितने वेरिएंट्स हम डिस्कस कर सकते हैं वो करें. और जैसे मैंने आपसे कहा कि अगर आप मेरे चैनल पे नए हैं तो इसको सब्सक्राइब करें, लाइक करें, जहां आपके पास कोई प्रॉब्लम आती है कमेंट्स करें. और अगर मेरे चैनल पर जो है वो मेरा नंबर दिया हुआ है उसको मैं यहाँ भी लिख देता हूँ. अगर आप चाहें तो इस पर व्हाट्सएप पे मुझे جو ہے وہ رابطہ بھی کریں مجھ سے کہ جہاں بھی آپ کو پرابلم آ رہی ہے. 03323066428. My name is Mohsin Naqvi and I have been teaching physics since 1980. So just take the advantage اور کوشش کریں کہ چیزوں کو آگے بڑھائیں. لیکن سکسیس کا کوئی شارٹ کٹ نہیں ہے, اس کے لیے آپ کو محنت کرنی پڑتی ہے. So this is what we have. Inshallah, see you soon. Take care. Allah Hafiz.